Hey everybody, Mr. Berry here. We're talking about notes here for higher degree polynomials, looking specifically at graphs and zeros or roots or x-intercepts, many ways that we talked about that. When it comes to our higher degree polynomials, however, so want to make sure we point out that a degree of a polynomial is a reference to the largest exponent in the polynomial. Now, obviously, we want to make sure that when we have something written out, we have it in descending order, with our biggest exponent in the front, the constant if there is one in the back. But besides that here, what I want to do is just kind of show you and go through here, in this video at least, different ways that these functions can appear. And then down here at the bottom, talking about the maximum number of solution zeros, and then as well maximum number of bumps or turns in the graph. So I'm going to start off with referencing what we're used to seeing and what we've seen before, at least so far in the class, which is our linear functions, which we saw a lot of in Algebra 1, quadratics, which we spent plenty of time talking about here in Algebra 2, and then we're going to move on to cubic, which has a higher degree of 3, quartic, which is a polynomial with a degree of 4, and then quintic, which has a polynomial that has a degree of 5. Now, I'm going to go ahead and draw what we already know linear and quadratic to look like. So for instance, if my graph here for a linear function is positive, a value is positive, we would have a positive slope. That's how it's kind of referenced in linear equations. It would look something like this. And again, there's many, many different ways we can write this. And if it was negative, it would be going down from left to right. And it doesn't necessarily have to go through the origin. But that's generally speaking what we saw back in Algebra 1, something that looks something like that with a positive slope and a negative slope. Quadratic, something we've been talking about here in Algebra 2. If its a value is positive, we know that our parabola is going upwards. As I crack my pencil, there you go. Jeez. Quality of pencil, I'll tell you. Here we go. So if our a value is positive, we would have something that looks like this. A value is negative. We know that we would have, I don't know, frowny face going that way for that. So just a couple things to point out here. We're looking at a maximum amount of situations where the number of solutions is 0. So this isn't necessarily what has to happen. It's just the maximum amount of things that could happen. So here are my solutions in the pictures that I drew. We got our x-intercept there, our x-intercept there for our linear functions. The maximum number of solutions or zeros there would be the number 1. Over here, we're looking for when we cross that x-axis. And again, we're looking at maximum situations, so it doesn't necessarily have to be this, but we're looking at maximums. And for each of those pictures, I have 2. Now, I do want to point out here underneath there, it says maximum number of bumps or turns in the graph. So, for instance, when we're referencing that, we've seen this in parabolas. Right there, or right there is a bump or a turn. You can see for each of these pictures, there's one. There's one. That would be the maximum number of bumps or turns in the graph. 1. For our linear functions, there is no bump, there is no turn. It's just shooting straight up, or in this case, it's shooting straight down. There are no bumps, there are no turns. So for this, I'm going to have 0. Now, just taking a look at the 2 examples that we're used to, this is 1 greater. The number of solutions is 1 greater than the amount of bumps. And that pattern will continue on as we go throughout these cubic and quartic and quintic, and we move so on and so forth. And the way that we can base that on, or at least take a look quickly at this, is linear is odd, right? So our exponent here is 1. That is an odd number. And our quadratic would be a polynomial that has a even exponent.